I don't need math in everyday life. Math is hard and confusing. I'm never going to use this. We said or heard those words at least once in our lives, but how much truth is in those statements? I've decided to see for myself and to compare different mathematical topics in the most accurate way. In a tier list, of course. I'm a little bit biased. I like math. I used to do a lot of it in high school. My friends and I had this competition to see who can do as many mathematical questions as possible during the class. I don't know how no one bullied us, but it netted me very good grades and other benefits. Because of this, I didn't have to learn it at home or do any math homework. Math isn't like history or biology. If you don't understand basic concepts, you will struggle with everything after. So I may not share some of your hatred for mathematics. In this video, I will try to rate most popular mathematical concepts based on how useful and impactful they are in everyday life, how useful they are in science and engineering, bonus points if it is used in something important, and last, impact on pop culture, memes, how widely known they are, and maybe some personal observations. I know most of those topics by hand from college, but I am not an expert. We will go from elementary math that we all learned at some point to some of the most advanced applications in science and engineering. Let's begin. Basic numbers. Without numbers, there is no math. Even letters are just numbers in disguise, so I don't think there is anything more important than numbers. Extremely useful in everyday life, counting, reading signs, and various kinds of important labels. They are even printed on money, so there is no denying it. On the meme front, they fare pretty well. Numbers like 69 and 420. And my favorite, -4 degrees, which looks like someone dropping a fat one. Even with all of this, I cannot give them S rank, because they are pretty bland. When you think about mathematics, you don't think about just numbers. So A tier, addition and subtraction. Fundamental, present in almost every field of mathematics, from elementary level to most complicated topics. This is what we use most frequently in our lives. Prevalent in memes, iconic symbols, S tier. Multiplication and division, same as with previous ones, used almost everywhere. A bit less prevalent in common use, but still very beneficial. Weaker pop culture presence, not as iconic as plus and minus signs. Still A tier. Fractions, percentages, and decimals. First expansion to basic numbers. Fractions are prevalent in many equations. Present in real life, on alcoholic drinks, in banking, dividing things equally, and understanding that a third-pound burger was actually a good deal. Percentages are decently memeable, and the percent sign is iconic. B tier. Exponents, roots, and logarithms. They let you do the same thing, but from a different angle. In everyday life, maybe to see how many things are in square grid. On more scientific level, logarithmic scales are useful, for example, when dealing with sums. Meme potential is very low, mostly puns. D tier. Arithmetic. This branch of mathematics takes into account all previous numerical operations. Overall, it is useful for everyone. You need to know how to add or multiply things and in what order. It is a base to more complicated equations and concepts. When you think about math, probably in some form, it is arithmetic. A tier. Next, elementary algebra. Uses variables which allow for outcome to change depending on their value. Most people can benefit from knowing basics. One of the examples could be calculating ratios. In science and engineering, it is a must. X and Y are widely recognizable, used in memes, and are usually one of the first things that you imagine when hearing about mathematics. S tier. Linear equations and functions contain variables and their solutions form lines in Cartesian coordinates system. Not as commonly used, but in some cases can provide useful information. Speed, distance, time, wages, all of those usually exhibit linear patterns. In reality, many phenomena can be described as functions, and often simplified to linear forms, overshadowed by other mathematical concepts in pop culture. C tier. Polynomial functions, more complicated than linear, form squiggly lines. On a daily basis, if you even use functions, it will probably be linear. In science and engineering, they have their uses, but half the time they get approximated to linear functions anyway. They are not memeable and iconic, minus points for how much of attention is put in school on quadratic equations to never be useful. F tier. Geometry, shapes in 2D and 3D, relations between volume, mass and size. In some cases, extremely useful, especially when building something from scratch, or even cooking. Basis for many advanced topics and calculations. Since this branch uses shapes, it is ever present in internet and pop culture. S tier. Trigonometry, angles, rotations, triangles, waves, circles and spheres. It can be found in all of those. Many physical phenomena can be described by trigonometric expressions. It has a variety of uses in scientific and engineering fields. What probably matters the most to you is that many navigation systems use it. Planes and GPS. It also can be found in architecture and geology. Overall, B tier. Statistics, everything concerning data, averages, minimums and maximums, mean values, trends, even those basic concepts can be used in your projects, and finances, one of those branches which connect theory to practice. Experiments, surveys, analytics, all use statistics to gather and process data. It has a solid presence in pop culture. A tier. Probability, branch of mathematics concerning events and how likely they will happen. Risk assessment, weather reports, insurances and trading are most common everyday uses. In science, it is basically the same, to judge how likely a specific outcome is to happen. Usually when calculating it, you get some abysmal numbers. Memes are not funny, and knowing my luck, it is a bunch of crap anyway. F tier. Advanced numbers, irrational, imaginary and complex numbers. Pi is the only one that is commonly used. You want to know if it's better to buy one large pizza or two smaller ones. The more advanced you get, the more you will see those numbers in various equations. Also, pi is widely known, iconic and used in memes and slang. A tier. Now, since we reached this point, most of the population won't use this part of mathematics. That's why I will consider more what impact can those have on your life. First, vectors. For average person, not important. For graphic designers and engineers dealing with velocities, accelerations and forces, extremely important, but also could be annoying. When you see vectors in mathematics, suddenly everything is 2 times more complicated. Mostly known from vector graphics, F tier. Matrices. Instead of doing every mathematical operation on its own, you can slap them into a matrix and do them all at the same time. For you it doesn't matter, but for your TV, phone or PC, very much. Analyzing and computing data, making robotics work. You even have this movie, I don't know if you heard about it. A rank. Integration. You can think of it as a way of getting closer to reality from just theory. When dealing with complex shapes and functions, it is almost required to use it. For example, to calculate volume, area, and other useful data for engineering applications. You can divide area under function into easier to calculate infinitely thin slices, and then just add them up. That's the gist of it. They are used when designing parts in most things you use, but mostly all calculations are done on computers. Also, the integral sign is what you probably think when someone talks about hard math. S tier. Differentiation, like other side of the coin of integrals. It allows you to see how something changes. Integrating goes from function to area, and differentiation from area to function. It gets the same usage as integrating, but it is pretty forgettable, like the less loved child of calculus. B tier. Speaking of calculus, this is what uses integration and differentiation. When stuff gets too complicated, you use calculus. Instead of calculating area of triangle like this, you can say that its area changes according to this function and use integral. Extremely useful, almost mandatory the closer to real life applications you get. Widely known, synonymous to top level mathematics. S tier. Abstract algebra. It deals with fields, groups and rings, which doesn't sound like much. You can think of it as algebra that you use when things don't follow usual pattern. Like there is 24 hours in a day, so 24 plus 1 normally adds to 25, but in this case it equals 1. It is extremely useful when dealing with vectors, but you almost always want to go back to normal algebra, mostly used in physics and computer science. F tier, because I hated it during my engineering studies. Mathematical logic. It can be summed up as a way to find if something is true or not, and if it even is solvable and possible. If you are interested in electronics or programming, you use it all the time. Or, and, not, those are logical operators. On a deeper level, it is present in bases for computer science, circuit design, and AI. It gets bonus points for logic being present in every part of our life. B tier. And that is how the final list looks like. Just remember, I am not an expert, and many of those could be placed higher or lower. Probably I could include more mathematical topics in this list, but it would be messy and confusing. If you want to make your own list, I will put a link in the description. As always, if you enjoyed it, subscribe, like this video and leave a comment. I try to keep this video as short as possible, so if you have more experience in any of those topics, feel free to share. It is always good to learn something new.